Hi, welcome to Parkson's 101 training for the HiOx aeration system. My name's Mark Razor and I'm the product manager for the HiOx system. The topics that I'll be discussing in the next few minutes are the aeration panel process in a wastewater treatment plant, an overview of the aeration market, some theory on oxygen transfer in wastewater, the evolution of the HiOx aeration panel, some product features, performance testing, and economics of the aeration system. This is an overall schematic view of the various processes of a wastewater treatment facility. The area of the system that we're focusing on is aeration. Although it's shown here as a relatively small portion of the overall system, aeration generally takes up the largest portion of land space in the plant and is the most significant user of electrical power in the plant. Within the aeration process, there are several ways to transfer needed oxygen to the wastewater. This chart generally shows increasing operational efficiency, moving from the left to the right. Surface aerators transfer oxygen to the water by splashing it up into the air to create large contact area. Although they can generally transfer large quantities of oxygen, they have limited efficiency as well as other operational reliability issues. Of the submerged technologies, sparger turbines are a bit of a cross between a surface aerator and diffused aeration, with efficiencies above surface aerators in a somewhat limited range. Static tubes are an older method of trying to create fine bubbles from coarse bubble diffusers. Jet aerators can approach fine bubble diffuser efficiencies in deeper basins and are mostly utilized in sequencing batch reactors or where wide variations in oxygen requirement and basin mixing requirements exist. Fine bubble submerged diffused aeration is the most common type of aeration technology in use today, as it's proven, it's cost competitive, and provides efficient performance. The most efficient aeration systems today are the panel or strip type diffused aeration systems. These devices create smaller bubbles than standard fine bubble diffusers, spread them across a higher percentage of the basin area to produce the highest efficiencies available. Parkson's HiOx UltraFlex aeration panel uses the first of these devices in the U.S. and is a leader in this type of aeration device. Surface aerators can float on the water surface or be mounted on rigid platforms. Their most attractive feature is lower initial cost. You can see how these surface aerators splash the water into the air to transfer the oxygen. This method, however, also results in greater transmission of odors, cooling of the wastewater, and freezing problems in colder weather. Tube diffusers were one of the earliest fine bubble devices. Parkson licensed the first tube diffuser with a flexible membrane in the U.S. and developed it to lead the entire market into membrane aeration devices. Many other diffuser manufacturers followed us into this market. Disc diffusers were initially introduced using porous ceramic materials. Biological fouling problems eventually led them to using membrane technology like the tubes. Disc-shaped diffusers can be manufactured and installed at very competitive prices, and they're typically the low-cost leaders of the diffused aeration industry. The Avivo or AeroStrip diffuser is very similar to Parkson aeration panel and was developed by a former licensing partner. It uses a nearly identical membrane to the Parkson HiOx panel with a slightly different fixture geometry. And this is the HiOx UltraFlex aeration panel. Through continuous improvement, Parkson has developed the panel aeration through several generations of configurations, arriving with this newest design, which uses no rigid bottom plate and is considerably lighter in weight and easier to install. There's individual control to each panel for complete control distribution and an easy isolation in the event that one's damaged in operation. The large aerating surface provides efficient, wide distribution of bubbles for maximum oxygen transfer efficiency. Now to look at an overview of the market. These charts provide an idea of the size of the North American aeration market. It's a sizable market worth nearly $100 million, with a large segment currently dominated by Xylem or Sanitaire, who's been a low-price leader in the disc-shaped aeration diffuser market for many years. Continued development will put the HiOx aeration panel into a position where a competitive purchase price together with low air supply horsepower usage will provide a product that's significantly less expensive to use over its lifetime. Just a little background on the science of oxygen transfer into water. Our main objective is simply to transfer oxygen into the water. The oxygen doesn't treat the water, but basically supports bacteria that do the treatment of the water. Since oxygen is in a submerged bubble, is transferred to the water through the surface of the bubble, and smaller bubbles have greater surface area for each cubic foot of air, we want to create the smallest bubble possible. Smaller bubbles also rise through the water at a slower rate, providing more time for the oxygen to transfer to the water. The degree that bubble surface increases with decreasing diameter is shown by this table. You can see that a bubble 1/10 the size in diameter has 10 times the surface area, leading to more effective transfer of oxygen for a given amount of air. The results of the small bubbles and high degree of floor coverage using HiOx provide an analysis of the present worth of the complete life cycle investment similar to this. You can see in the detailed view that higher investment up front appears to be a disadvantage in the eyes of the HiOx. But as the system operates through its life cycle, the energy savings vastly favors the lower energy cost of the HiOx. You can imagine the savings when looking at the savings of many installations that last 10 to 15 years between replacement of panel membranes. This installation increased its treatment capacity by installing HiOx panels, as seen on the left. And at the same time, it significantly reduced its energy usage, as noted by the horsepower reduction on the right. As I mentioned earlier, we've progressed through several generations of improvements in the product over the past 25 years. Here you can see the results of these improvements that have significantly reduced the weight, complexity, and cost of the device. The designs on the left and center required more than 100 parts for assembly of a single panel, while the UltraFlex unit on the right uses less than 20 and is less than half the weight. The HiOx UltraFlex panel features include a high-strength polyurethane membrane with over 25 years of experience, a nylon-reinforced 2-ply polyurethane base support or backing material, stainless steel frame construction, and a long useful life that's typically 10 years or more. The lightweight design makes the panel easy to maneuver in the basin during installation and maintenance. Membrane replacement takes only about 1 to 2 hours per panel from start to finish. For performance testing, we have the capabilities to test our systems at full-scale operating depth for development and performance compliance. Our facility includes a 32-foot deep tank, air supply blowers, automatic data recording, and limited lab capabilities. For quality assurance and production, we test every panel shipped to our customers for air distribution and pressure characteristics. The challenge to our customers is providing the sufficient transfer of oxygen to the aeration process while minimizing energy costs and capital equipment expenses. The solution available from Parkson Corporation is efficient aeration using the HiOx UltraFlex aeration panel. Benefits are low cost, low energy cost, consistent performance over time, easy operation and maintenance, and long membrane life that's generally more than 10 years. It turns into a very green technology. That's everything. I appreciate your time and attention. Thank you very much. Please feel free to contact me with any questions you might have.